Hello and welcome to this video on completing the square. There are several reasons why you may wish to complete the square, and these include solving equations, which we covered in our last video, to find the minimum or maximum value of a quantity, and to find the turning point of a quadratic curve. So let's start by thinking about finding the minimum or maximum value of this quadratic, y equals x squared plus 8x plus 6, and its turning point. Well, I've drawn the graph and we can see that it's got a turning point at -4 and -10. But how can we tell that from the equation? If we write the expression as a completed square, as y equals x plus 4 squared minus 10, then because if you square something, the minimum value it can have is 0. That means x plus 4 squared has a minimum value of 0. You're either going to get 0 or a positive number when you square something. So that means that the minimum value of x plus 4 squared is 0 when x is -4, and the whole expression for y has a minimum value of -10. So therefore the minimum value of this quadratic is y equals -10, and it occurs when x is -4, giving us a turning point of -4, -10. For this quadratic, where the x squared term would be negative, it's already written in a completed square form. When x is 2, the bracket is 0. So the maximum value of y will be 15. When we do 15, take away 0. And that occurs when x is 2. And from the graph, we can see that that corresponds to a turning point of 215. But notice this is now a maximum value of y rather than a minimum, because the quadratic curve is upside down. Okay, so here are some more examples where we've been asked to identify the maximum or minimum value of y and state the corresponding value of x. For the first 4 examples, they all have a positive x squared term, so these are all going to be minimums. So in number 1, the smallest value of x minus 4 squared is 0 when x is 4, and hence the minimum value of y is going to be 10. For number 2, we need x to be -9 to make the bracket 0. And that gives us a minimum value of y of -18. Number 3 has been written the other way round, but it still works in the same way. So the minimum value of y is 63, and that will be when x is -3/4 to make the bracket 0. For number 4, the 2 is irrelevant. It just stretches the graph, but it won't actually affect what the minimum value is, because x minus 5, when that is 0, 2 times 0 is still 0. So when x is 5, we get y equals 0, take away 7. So the minimum value of y is -7, and it occurs when x is 5. For the last 2 examples, 5 and 6, these are both maximum values of y, because the x squared term would be negative. For number 5, when x is -8, we get a maximum value of y of 24. And in number 6, again, the number in front of the brackets is irrelevant. But when x is 2, we get a maximum value of y of 37. So you should already know how to write an expression in a completed square form when you have a positive x squared term. But how do you do it when the x squared term is negative? Well, here's an example. We've got 8 plus 6x minus x squared. And my recommendation would be to actually make everything negative, or at least the x terms. So if I put a negative sign outside some brackets, I can change every single term's sign. So we've got a positive x squared, a -6x, and a -8 in the brackets. The next step is to complete the square on the x squared minus 6x, which gives me x minus 3 squared, take away 9. We're still taking away the 8, and we've still got that negative sign out the front. On the next line, I've simply done -9 take away 8 is -17. And on the final step, I'm now getting rid of those big brackets with the negative sign out the front. So the 17 becomes positive, and we are taking away x minus 3 squared. Here are some questions to practice, so please pause the video and have a go at them, and then the answers will be on the next 2 slides. These are the answers for the first 3 questions. These are the answers for the last 2 questions, and what I've done here is I've taken the coefficient of x squared outside the brackets instead, and I've actually left the other number that's on its own separate. Here are some more questions to practice completing the square, the answers for which will be published in a separate PowerPoint slide. So please pause the video and attempt these questions. Finally, if you want some extension questions, I have provided you with some minimum point challenges, the answers for which, for a couple of them, are on the final slide. So as you can see, answers for a couple of the questions. The other questions have an infinite number of answers, so therefore I have not provided you with solutions for them.